a typical thermochemistry problem. And thermochemistry, without going too much into the depth of it, is the study of how heat and other forms of energy change and interact with in chemical reactions or physical changes in matter. So we have here a problem that says a certain gas expands from 2.0 liters to 6.0 liters at a constant temperature. Calculate the work done by the gas if it expands. So there are a few things that they're not explicitly telling us, but we need to know. For example, the constant temperature means that there's no change. So we don't have to go into that. And they also ask us to calculate the work done by the gas. It's very important first to know that work has a formula and is equal to negative pressure times the change in volume. That change in volume is equal to the subtraction of the final volume minus the initial volume. And we have two scenarios here. The first scenario tells us that the gas is expanding against a volume. So a sketch might help us see better what is happening here. So we have the gas inside the container, and we are going from 2 liters to 6 liters. So there's more volume inside the container at the end of it all. So the piston here is going up. In the first scenario, it's against a vacuum. Vacuum means that there's no pressure. So in the first scenario, if we calculate work, guess what? There's no work being done. Because even if we do the subtraction of 6 liters minus 2 liters, which equals 4 liters, we multiply that by 0, there's no work being done. So the work in the first scenario will equal to 0. However, in the second scenario, there's a constant pressure of 1.2 atmosphere that now makes the gas work a little more. So let's take this out and let's do number 2. So against that pressure of 1.2 atmosphere, we're gonna insert that in our formula, which is negative 1.2 atmosphere times the difference in volume, which is the final volume, 6 liters minus 2 liters, which is 4 liters, which gives us 4.8 when you multiply it, negative 4.8. And now we have to multiply the units, which is liters times atmosphere. However, now we have to convert our answer to joules because we measure work in joules. So as our last step, we are going to change this using our conversion factor, where per liter times atmosphere, we have 101.3 joules. So our final answer would be negative 4.9 times 10 to the power of 2 joules. We could also write it in standard notation using the correct amount of significant figures, which would be also, let's put it right here, negative 490 joules.